right, good morning, class. As you are preparing for the upcoming cut that will be next week, there's some things that I felt I needed to mention to help you, not really like to try to help you uh, grasp uh, the kind of questions that are likely to be asked, and in a number of exams, either CATs or the final exams, nomenclature normally features in that as an engineer who's done organic chemistry, you are expected to be able to name organic molecules. The reason is that if you're likely to be in the field somewhere doing a project, and then you come up with a compound which happens to be an organic molecule, and it is a new compound in that it has not been documented before. The documentation in something called chemical abstracts, uh, so that other scientists will be referring to that molecule, it means that you must put down the compound or the molecule which you have made in a standard IUPAC nomenclature, to which anyone can look at that name and then they can be able to generate the structure. So what I've done is just to give you, I've just put a simple molecule, and I want to show you that there are normally two ways in which examinations dealing with nomenclature they actually asked. One of them is that you can be given okay, you can be given a structure, like in this case. Okay, let me highlight it in. Okay, this pen is not working. Let me use this. So you can be given something like a structure, and then you're told to do what? To come up with a name. And what I've done is to try to show you and the process in which you can be able to get the name. I think it's something which I've discussed in the last presentation, but I think this just like to refresh your memory. So the first thing is that the questions are likely to come in. You're likely to be given what you call a bond line structure. Suppose with this CH3, CH2, this just try to help you, but if you're likely to be given a structure, it's going to be in a bond line form. So that in this case, I've just given a simple structure like this one. You just know that it's a 4 atoms molecule, which in this case you're going to say it's a butane, yeah? And then the second thing which you'll need to look at are the functional groups, yeah? Or the substituents which are attached. There's a bromine, there is an NH2 which if it's the main functional group, it's going to be an amine, but if it's a substituent, it will be an amino. Then there is an OH, which if it's a substituent, it will be a hydroxide, but if it will be the main functional group, it will be called an alkanol. An alkanol means it's an alkane, and then it will be adding with an OL, yeah? And then I think according to what we said is that the hydroxide is the highest priority amino, and then halogens and something like alkyl substituents, they run together. So that is number one, OH, NH2, and something like a halogen is going to be something like number 3. And then I think it's just to emphasize, but I think I mean I've mentioned it. I don't know whether it's directly or indirectly, but I think I need to mention it very clearly. If it's said to be an alkanol, there is an A here after alk for the surface, indicating the number of carbon atom. This A indicates that there is no double bond or a triple bond in the structure. Yeah. If there is a double bond, the A, it's if there is an alkene, then the A changes to an E for an alkene. If there is an alkyne, the A changes to the Y. Please note that A is for an alkane. It means there is no double bond. If there is a double bond, the A changes to an E. If there is a triple bond, the A changes to a Y. So that if there would have been a triple bond, it would have been a butanol. You understand? If it's an alkene, it will be a butanol. If there is, like this one is an alkane, then it's a butanol. Butanol for an alkane. Butanol, for example, it's a double bond an alkene, and triple bond it means actually be called a butanol. And then because the alcohol is the main functional group, the name will end with an OL. So based on that one, then you are started. Then you know that sometimes in the bond line structure you can be able to put 1, 2, 3, 4, but sometimes as you are starting off, you can be able to now stretch it like this and just say, hey, there's a CH3, there's a carbon with a bromide and an NH2 carbon like this one, and then you just put it and then you number it and know that because the OH is the main functional group and it is not on the terminal carbon, it means that I cannot put this one as carbon number 1. So this one, so I put carbon number 1 as the one which is nearest to the main functional group, which in this case is the OH. So that I'm going to start at 1, 2, 3, 4. And then you're going to say, based on that one, the name will be the amino group alphabetically. The amino group is on carbon number 3. The bromide group is on carbon number A, B, and then you're going to indicate that in the main functional group it's a butan, and then the hydroxide group, the alcohol is on carbon number 2. So that's the name. So that's the first method in which we usually test. You're given a bond line structure, and then you're told you have to come up with a name. But the most favorite way of testing, which is what you call which is supposed to make you the all-rounded, and I want to mention because you may not be able to escape this. You may not be able to escape this form of testing. Is that okay? This is what we know as the IUPAC nomenclature for this structure: 3 amino, 3 bromo, butan 2-ol. But once again, as I mentioned, the most and it is tricky because it makes use of a lot of your mental capability. You can be given a name, a name of a structure, and you're told that name is not correct. But you're supposed to use that name, that name which have been given, to generate a structure. And then from that one, then you're supposed to name that structure according to the proper IUPAC name. Are you understanding? Like in this case, I've given an example. You can be given a name like, so that in this case, there are 2 ways in which you can be tested. You can be given a structure, come up with a name. That's the simplest way. The second one, which is a higher level, is that you can be given a wrong name. But based on that wrong name, you can be able to generate a structure. And then from there, name that structure according to the proper IUPAC name. Like I've given an example here. Like there is a name here. Yeah? 2 amino, I hope you can see it correctly, 2 bromo, 3 hydroxy butane. So this name assumes that the main functional group is an alkane, which I think you know is not correct. But now it's telling you, hey, there's an amino group on carbon number 2, there is a bromo group on carbon number 2, and then there is a hydroxyl group on carbon number 3. And then it is a 4-carbon structure. So based on that information, you simply put a 1, 2, 3, 4 carbon structure. Carbon number 1, carbon number 2, carbon number 3, and carbon number 4. Yeah? And then based on that one, you just say, hey, there is an amino group on carbon number 2, and then there is a bromide group on carbon number 2, and then there is an OH on carbon number 3, and then there is no other function group. So based on this name, even if it's wrong, you come up with a structure. And then now, based on this one, you see that it is similar to what we have here. And then now, you can now name the structure which you have generated according to the rules. Like in this case, the OH is the main functional group. There is the NH2, which is an amino group substrate, and then the bromo group is also a substrate. So based on that one, then you know, hey, these are butan 2-ol, and then there is an amino group and bromo group, and then based on this one, you come up with this name. Are you seeing here? So this is the more advanced way of testing, and you need to know that there are 2 ways of testing. One in which you can be given a simple structure, I can be given a structure, come up with a name. The second, which is the more favorite method, is that you can be given a name which is not correct, and then you're supposed to generate a structure, and then from the structure come up with a proper IUPAC name. I hope it's clear on that. Those are the 2 ways in which testing of organic molecules, of IUPAC of organic molecules can be done. Now, the other thing I may need to mention is that you need to know about the physical properties of organic molecule. For example, the physical properties are like which one? Perhaps I may need to delete. Let me just try to see whether I've got something to delete. Okay. To wipe the board. Okay, let me close these buttons. So there is physical properties, yeah? So talking about what? Melting, boiling, solubility in either water or organic solvent, yeah? I'm just trying to think of other physical, or maybe something like maybe density, okay? By density, I'm just going to say, if you've got that organic molecule and then you probably put it in a solvent like water, how, assuming, assuming it's not, assuming it's not soluble in that solvent. By it being soluble, it means that it will form a homogeneous solution. If it's not if it's not soluble, then it's going to form 2 layers. Now you're going to say, this organic molecule, will it be on the top layer relative to the water, or bottom layer? In this case, if it is denser than water, then it will be at the bottom. If it is lighter than water, which for most organic molecule is like hydrocarbons, like petrol, whether we're talking about diesel, all those kind of things, they float on water. So in this case, the density will be less than 1. So there are those kind of things as the density. I think for now, at your level, I think there are these 4 aspects: melting point, boiling point, solubility, and also density. So for this ones, you to be able to really get to understand what you may be asked about those things, so you need to know about uh, intermolecular forces, because these are the forces which govern the melting point, boiling point, and also solubility. It means that if you're talking about in a place like water, then if a molecule has got can cause hydrogen bonding, then it's going to interact with a solvent like water. If it doesn't have hydrogen bonding and it's mostly like a hydrocarbon alkyl group, then it's most likely to be soluble in a solvent like toluene, or maybe something like petroleum ether, which is a hydrocarbon. So in this case, if there are no hydroxide groups and the rest, then it may be soluble in an organic solvent. But all those things you'll get in your notes. So melting point, it means that the ones which do not have a lot of intermolecular forces are strong in intermolecular forces, like what? The weak ones are what? I don't like to use the word van der Waal, because van der Waal is a combined form. So you need to know things such as London dispersion forces, ion dipole, dipole, all those kind of things. Yeah. So we'll be able to look at all the various intermolecular forces, including the hydrogen bonding and the rest, how they affect the melting point, boiling point, and solubility. Then you just need to know that for most of the organic molecules, the density will be less than 1 relative to water. I'm talking about kind of knowing these kind of things. You need to know about those. But for alkyl halides which contain halogens, the density is going to be higher than. So all those kind of things you'll be able to really look at those ones. The other thing that may need to know in this course is about the uses. When you're talking about this course on chemistry 2, because of the wide range of topics, we do not tackle chemical reactions. Yeah, but chemical reactions, selected chemical reactions, are tackled under the part 2 of the course. You're talking about, when we'll be talking about hydrocarbons, we'll be talking about combustion of fuels, yeah, whereby a hydrocarbon like an alkane, alkene, alkyne, it can combust in oxygen to produce carbon dioxide plus water. So in that case, we'll be talking about empirical and molecular formula and the rest, yeah. So there will be combustion analysis, and also put it in something which I'm going to call a calorimeter, whereby if that organic molecule is going to burn in oxygen, then it's going to generate heat, and the heat that's going to be produced is going to cause the container to be able to absorb the heat of the combustion, and therefore if that container is going to contain a specific amount of water, then that water is going to rise by a specific amount by a certain temperature range, and then from that one you can be able to work out back that anything which causes this temperature rise to rise by this Celsius, then it's likely to have been produced by a compound having this this energy of in kilojoules or maybe kilocalories. You're going to come to those ones, yeah. And then also in something about proteins, you'll be looking at a few reactions, for example, that there is a molecule here, they are coming together, an amino acid and amino acid are coming together to form something called a peptide bonds and the rest. So there are a few reactions here. And then the last type of reactions which you are likely to deal with, because there are 3 types of reactions, is an alkenes coming together to form polymer through something called free radical polymerization. Yeah. So there are these 3 types of reactions. There is the combustion, the general one for organic molecules. amino acids coming together to form proteins, to form something called peptides. Peptides, big ones, they form proteins. And then lastly, it's about what you call what is this thing you're calling polymers? Yeah, polymers, whereby uh, uh, an alkene like ethene coming together to form polyethene. It's called polyethene, something like that. So there are those three types of reactions that we'll be dealing with. But in general, because of the complexity, especially when we'll be dealing with aldehydes and ketones, they contain the carbonyl group. There are so many types of reactions we can be talking about, which we cannot cover in the time given. But the online, but the textbooks reference which I gave you, for those of you who may want, you can be able to look at the various reactions for the various organic molecules. But these three reactions, the combustion, the uh, the peptide and the protein formation, and also for the polymerizations, those three reactions you are expected to know as an engineering student. Yeah. uh, but for what's in the course is that you need to know from alkanes, alkenes, alkynes, alkyl halides, alcohols, ethers, uh, uh, amines, carboxylic acid. Did I mention aldehyde and ketone? So you need to know their uses, their general uses. Yeah. So for the alkanes, most of them are used as fuels, but I think you'll be able to look at that one. Alkenes, the simple alkenes, like whatever you need to know about polymerization and the rest. Benzene, oh no, benzene has got so many uses. Yeah. Benzene itself. Yeah, so you'll be able to look at the notes and then see the various uses for that one. Alkynes, alkyl halides, not to mention, but it's good to know some of the discontinued uses, like for alkyl halides, like they are now not being used as chlorofluorocarbons, like for CFCs, like in the fridges and the rest, because they harm the ozone layer and the rest. It's good to know what are the current uses, what are the previous discontinued uses. Yeah. And also on something like dichloro dimethyl trichloromethane, like the DDT and the rest, whereby it's not being used because of the way it harms the environment. DDT, yeah? It's a what? It's an alkyl halide, yeah? Something like that one. So we'll be looking at all those uses, alcohols. Not all alcohols. It's only one alcohol which is used by some people for talking about ethanol, but for something like methanol has got many uses, like in the combustion in the vehicles and other things, medicinal purposes, aldehydes and ketones like acetone, like for removing the nail polish for the ladies and those kind of things, amines, carboxylic acid have got so many uses. Yeah, so you'll be able to look at those, and all those things are in the various sections of the lecture notes. So you need to know about the uses of the various organic molecules. So I think I've just mentioned in a general manner, uh, because I do not want you to start focusing on the reactions of these organic molecules. Otherwise, you'll be looking at the wrong area. So nomenclature is very important. The physical properties which are governed by the intermolecular force, the various intermolecular forces, solubility, density, and the various uses and the rest. So these are the various areas. I've just put it in a general manner, things that are required for you to know regarding this course. So I think let me stop there. I've just given you an overview of what is required for you to look at, and I wish you well, even as you revise for both the continuous assessment test and also for the for the final exam. So I think after this you'll be able to say, hey, through this course on organic chemistry, I've been able to see how the application of organic molecules to the engineering. Yeah, that this is not an abstract course, but it has a lot of relevance for you as an engineer. You'll be able to say, hey, organic chemistry was really helped me in my career as an engineer, whether as a civil engineer, mechanical engineer, uh, mechanical, civil, biosystems, and also, oh God, I would have forgotten this, petroleum engineering, yeah, fuels and the rest. You'll be looking at under the fuels about how the various hydrocarbons, how they are extracted as crude oil, separation, the modifications to be able to, all those kind of things. So we'll be able to see all those kind of things and then say, hey, this chemistry has really helped me in my career. So this course is laying a foundation for what you're going to be doing in future. Yeah? So thank you very much. I think you've been able to really understand a few things here and there. And I wish you well, even as you revise for the CAT next week. So there will be so for the civil engineering, the CAT will be on Wednesday, and the one for the mechanical, the other group, it will be on Thursday, and the two CAT will not be the same. Yeah, yeah. So the one for the civil engineering and the one for the other groups will not be the same CAT, but they will be talking about similar topics, but the CATs will be different. So there will be two CATs for the groups. One for the civil engineering on Wednesday, 31st, and then the one for the other groups on Thursday, from 10 to noon. The one for the civil, it will be from 8 to 10. Please note those two times. So I wish you well. I believe what I've talked about in the 27 minutes, I believe, has been useful. So wishing you well. Next time we'll be talking about beginning part 2 of the course, where I'll be talking about proteins, carbohydrates, everything on the fuels. All those kind of things will now begin officially after this. So I wish you well, and work hard even as you revise, and just get good marks. Yeah? This course is not hard. Wishing you well. Thank you. Okay.